Welcome to another episode of the podcast. Dr. Thomas Hemingway here. Make sure you subscribe and hit that notification bell so you never miss out.
All right. So we have an amazing guest today, Dr. Kara Fitzgerald. She is one of the world's experts on longevity, on methylation, on all things integrative and functional medicine. Just a really smart gal. So we're excited to have her on today. She is joining us all the way from Mexico at the moment. And so what a pleasure to have the Zoom technology and have the ability to chat like we're in person. So Kara, welcome to the show.
It's awesome to be with you today, Thomas. Thanks so much for inviting me on.
Oh my gosh, such a pleasure. So fun. We were just talking offline about your daughter who may or may not jump in, and we welcome all kids. I have 6 myself, as you know, and kids are amazing. And I think now maybe it's got you thinking a little bit more. Obviously, you've been on this journey for a while, and I know you did a lot of time in the lab in years past and things like that. Tell us a little bit about your backstory, how you got interested in the integrative and functional medicine as well as longevity. Just tell us a little bit about that.
Yeah. So if I go way back to before I went to medical school, well, even, all right, I don't want to, I just, you have a carte blanche to interrupt me at any time.
Oh yeah. No,
for any reason.
It goes both ways.
Long or if I get too arcane, definitely. But I was raised by a mom who was aware of, quality food. I mean, we were sort of, when I was a kid, health food was definitely an outlier, and we were sort of the weird family because my mom was savvy. Of course, it was a career-defining thing for me, and I appreciate it to no end. But, at the time, she was feeding us sardines. I remember
Wow.
clearing my lunch table because I had, whole wheat mega bread that she made with sardines in my lunch, and cleared it. It's like maybe it's a mild trauma still. Anyway.
That's awesome. I love it.
No, we took brewer's yeast. We took, vitamin C. Anyway, so she had this. She knew, she had a sense of what was healthy. We made yogurt. She wanted us to have live cultures and stuff like that. Flash forward, and so my biggest threat to her when I was a little kid was, I'm going to eat a whole thing of Oreos, Mom. When I move out, I'm going to eat a whole thing.
When you move out. Oh, so
when I move out,
there was nothing in the house.
I'm going to eat a whole thing of Oreos, Mom. That was like my threat.
Oh, that's hilarious.
I know, it's so funny. So I did. I ended up imbibing in the standard American diet and for a while, but I just, I got sick. I actually developed fatigue. So I had kind of like, I think I had probably acute mono. I was in my 20s, and then it moved into, something that I just wasn't shaking for a long time. And I was, burning the candle at both ends and kind of getting ready for grad school. Not quite sure what I was going to do, but I ended up getting really pretty profound fatigue. And I was renting the upstairs from this woman who was like 90 and just vibrant and dry, just this fabulous human being who I absolutely loved. And she recommended that I go and see her doctor. And it turned out he was a naturopathic physician. Let me just actually preface by saying I went through the conventional care model and, didn't get care. They just didn't know what to do with me, and my thyroid numbers were fine and whatever. One urgent care guy recommended a B complex, which was so much more advanced than anything else I had received, any other information. But so she ended up referring me to her physician. Turned out he was a naturopathic doctor. I had not been to an ND before. He got me better really quickly with very basic intervention, something that a 20-something-year-old kid would do. So he gave me a botanical combination. He gave me some CoQ10. He did diagnose me with Epstein-Barr. I think he ran antibodies on me, but just simple dietary tweaks. Kara, maybe consider a vegetable now. And I did what he suggested that I do, and I got better. And I ended up getting a job in a health food store. And anyway, these events coincided around time I was deciding graduate school, and I wanted to go on to become a physician. And so it was clear to me that I would go into naturopathic medicine. And that's how I ended up out in the Pacific Northwest at Portland, the National University of Natural Medicine. And then But I quickly discovered that I had a penchant for biochemistry and laboratory science, and ended up just being gifted to have the training of a naturopathic physician, but then get right into a lab for my postdoctorate training under the direction of Richard Lord, who was a really highly regarded nutritional biochemist, and as well as a concurrent residency in integrative medicine. So it was just a beautifully rich training that just feel really grateful for. And I think having been in the lab just set me up for what would become, why I'm talking to you today. And that's an interest in epigenetics and being able to look at gene expression and kind of being on the frontier of that technology, which is extraordinary. I mean, when we started our study, you weren't able, the epigenetic tests looking at DNA methylation, those arrays were not available outside of the research setting. And we just started our study in 2018, very late 2017. And our study ran through 2019. So, 2 days ago, basically, these tests weren't available outside of the research setting. And I think my background really enabled me to want to use such advanced technology to look at gene expression. But our intervention is really, pretty old school naturopathic medicine. And so I guess, when you look at it, I think I was probably the right person for this job.
Yeah, and you married the two beautifully. I mean, it's I don't know how much we'll geek out, but I had a minor in biochemistry and also in physical chemistry. I was in the lab a lot in my both undergrad days, and I love I love geeking out on the chemistry. So maybe let's back up just a little bit for all of our viewers and listeners, just kind of defining a couple of the terms you've already mentioned. First of all, I think my audience is fairly familiar with epigenetics and what that really means, but maybe you could just kind of define that and just with that kind of speak to, the traditional genetics that we always think of, Mendelian genetics, what we have in our so-called genes that we inherit from our parents, and how much of that plays into disease and health as opposed to the magnitude of what epigenetics play, and maybe define it with that sort of take.
And you know what? This is super tangential, but ask me. A friend of mine just received, he just had a heart transplant. He just received a new heart. And I was thinking about that epigenetically. So I want to put a pin in that and circle back to you on that. He's at Yale right now. So yeah, back in 2003, as you know, we mapped out the human genome. We figured out we have 23,000 genes, like we cracked that massive code. And we thought at that time, scientists, we really thought we had the Rosetta Stone to diseases, right? So genes A and B cause diabetes, genes, X and Y cause heart disease. Here's where cancer is. So if we just manipulate our genome in some way, like we've got the Rosetta Stone, we've got the solution. It was kind of amazing how cavalier that was, but I mean, I think that's the nature of humans, right? And so we realized very quickly that, in fact, it wasn't the case, that our genes really didn't tell us a heck of a lot at all. It's the exception that someone has a genetic disease, like my friend getting a new heart who has a very clear genetic cardiomyopathy in his family, and he requires a new heart now, and it's a miracle that he has one. The vast, 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 vast majority of us, and the vast majority of any kind of issue that we're going to confront health-wise, comes from epigenetics, comes from our own choices. So our genome, we realize, we get, it's pretty immutable. We get what we get, and there's not really much that we can do about it at this point. So when we realized that we couldn't define diseases by having mapped out the genome, we quickly pivoted towards putting attention on the epigenome. So that is above our genetic material. The epigenome dictates what genes are on and what genes are off. So if you think about it, we have the same genetic material in every single cell, every DNA containing cell in the body, the same stuff. Right? But my eye isn't my liver, isn't my heart. Like everything is expressed differently. And the way that we express is turning certain genes on and suppressing other genes. And DNA methylation, which is what I am studying, is a key epigenetic mark. It's a key biochemical process that influences turning genes on or turning genes off. A methylation group is a carbon with 3 hydrogens, if we go back to high school biochemistry. In the literature, if you look at read epigenetic studies, they denote a methylation group as a red lollipop. And so you'll see a gene, you'll see the promoter region of the gene. That's the area that turns it on and off. And if it's dotted with these methyl groups, these red lollipops, that gene is effectively inhibited from being turned on. It can't be transcribed. Conversely, we can either inhibit red lollipops from landing on a gene, or we can actively remove them. And then that gene can be turned on and transcribed. So yes, there's a continuum of expression. Like my eye cell will never turn a retinal cell isn't going to become a liver cell, for example. Like those are very rigorously and reliably suppressed and controlled. But there's vast swaths of genes that our choices, how we're living, if we're, how well we're breathing, eating, moving our bodies, experiencing our life, influence what genes are on and what genes are off. So we went from thinking our genes, our DNA, completely dictated our fate, and we were absolutely powerless, to this about face into the era of epigenetics, where in fact we're now realizing that our best life, we're truly in the driver's seat, really, the vast majority of us, to live our best life. It's up to us.
Yeah, no, that's so empowering, because when I was in medical school, we didn't talk about this one bit. I was in medical school in the 90s, and we did not talk, I don't think, a single day about epigenetics and many other things, right? We never talked about gut health. We never talked about so many other things.
Yeah.
But
or
I think
nutrition, for that matter.
not very much, very little, little. I was, big name UC San Diego school. We did biochemistry really well. We actually did a lot of biochemistry. We had some amazing biochemists as faculty, but we didn't get too much into nutrition, and certainly not into epigenetics at all. And I think, exactly as you stated, that it's so empowering to know that what we do and what we don't do, the choices we make on the daily, are actually the biggest levers with respect to our health outcomes. The biggest 90+% within our control, which is so cool. And we'll get into your study in just a bit, but I mean, you showed that in an 8-week period of time, where you could see literally this biologic age reducing in 2 short months. And
I know,
I just think it's astounding. And maybe you can just speak to, so you talked a little bit about methylation. I think a lot of my audience is fairly savvy with this. I think they may think of the methylation that's involved with, the classic folate pathway, and thinking about the MTHFR, SNPs and things like that. But maybe you can speak to how these are, it's methylation is a chemical term, and it's the same process, but it's actually, we're speaking a little bit different than we might be if we were referring to the MTHFR, and then how we use that methylation to actually do that biologic age test, and how that's different, obviously, than our chronologic age. Maybe you can just kind of help us with that a little bit, so we can kind of get our feet grounded in the methylation, and how we can use that for measuring our physiologic or biologic age.
Sure. Yep. Absolutely. Yes. It's amazing to me how smart people are about biochemistry these days. Like, your listeners know the methylation cycle. It's so it's really cool and impressive. So methylation is happening, as your listeners probably know, in most of our cells all over the body, all of the time. There are hundreds of methylation enzymes. As I describe it on DNA, they're denoted as these red lollipops in the medical literature, but it's still it's that same carbon and 3 hydrogen, and it's a methyltransferase enzyme that puts them on. And so go over to where MTHFR is, and that's in the methylation cycle itself. That's basically the cycle that's making the red lollipops that we need, that then zoom over and that are used in other parts of the body. That methylation cycle, as your listeners know, is super nutritionally dense. And yes, and we can have variance in the quality of enzymes. So in our ability to spin that methylation cycle and make those red lollipops, some of us do it better than others. And that could be genetic, that could be a variant, but it also could be just burden. We can mess with our methylation cycle. If we're exposed to a lot of toxins, we're going to be diverting some of those some of those red lollipops towards eliminating toxins. Or if we're under a lot of stress, we're going to be metabolizing our adrenaline using methylation. So it does a lot of stuff. And conversely, if we're taking pretty good care of ourselves, we're going to preserve our need for those for other more important work. But it's nutritionally dense. It requires folate, B12, betaine, choline, a handful of minerals like potassium and zinc and magnesium, actually other B vitamins as well. And so there's just a lot of, it's a nutritionally dense and demanding cycle. So most people have an idea. And even if they don't know the methylation cycle, they know something like folate is good in pregnancy. And that is, to help with methylation in large part. So yeah, we want a good functioning methylation cycle. So people thinking in that area is spot on, but then know that it's happening all over the body. And my focus has specifically been on DNA methylation and demethylation. And so leapfrogging to your second question on biological age. So we have a chronological age, which by the way is going to become probably obsolete information in the not so distant future. People are going to really care primarily about how we are actually aging, how our biology is changing, our biological age. So chronological age is trips around the sun. There's nothing you can do about that. It's, you celebrate a birthday annually. Biological age is how fast our bodies are actually aging. I mean, that's, the wear and tear, the breakdown of our body. And we can measure that by looking at patterns of those red lollipops, by looking at patterns of DNA methylation. And in the clock that we used the original Horvath 2013 clock. Horvath is a scientist out of UCLA. He's actually now at Jeff Bezos's lab. He probably still teaches, but he's now at Altos. And there's 353 methylation sites in that clock. And that's what we looked at. And our intervention showed that we rearranged the location of those red lollipops in our study participants towards something more youthful, amazingly enough, as compared to the control group.
And that clock that you referred to, the Horvath clock, I think he was just kind of the first guy, right, that kind of described this technique. There's several different tests out there, and
yes.
which was the one that you used again? Was it the DNA age?
We used the DNA MH. That's Horvath's original clock. Okay. That's correct. We used that because you know what? It was the only clock available when we started our study. This is how rapidly the science is evolving. It was the only clock out there in 2017 when we were, working on our study design and so forth. Since then, and we used saliva also. So it's the strongest performing with the specimen that we used. Since that time, that's called a first generation clock. And now we're on to the third generation clocks. And we're using something in our practice. We offer something called the Peace of Aging, which is a third generation clock we can talk about if you want to later. But the technology is getting more sophisticated. But even as it is, that original flagship Horvath clock is still good. It's still a strong clock.
Yeah. And it seems like, just from my kind of nerdy biochemistry background that you also share, that this technique, I would think it would be more robust than simply measuring length of telomeres, which was kind of like one of the other ideas of how we can look at our biological age. But this, with, the computer power that we have now, I think, sky's the limit as far as like how many generations we're going to get and how much better each and every iteration may become. Yes. But is that kind of your thoughts as well, that this is a much better marker?
Yeah, well, certainly when you look at chronological age. So the original Horvath clock that we used was trained against chronological age. So it was trained to track with chronological age. Yeah. And the correlation was 0.96. So it tracked tightly.
Really well.
So if you compare to telomeres are about 0.4 actually. Correlation. So much, much weaker. Mm-hmm. The interesting thing, so Horvath's clock really does what it's supposed to do. It tracks with chronological age, but the wiggle room, if it was 1-to-1, it would be only a marker of chronological age. But that 4/10 less is where biological age is happening. So when you look at the data on Horvath's clock, it's a stronger predictor for morbidity and mortality for disease than is chronological age. So that was shown immediately, and it's withheld the test of time. It's still a really quality clock. So yeah, it blew telomeres out of the water, and I think even though it's still a good class, I think it's, it's becoming more refined. I mean, and you know what? What is today? I don't know when this is going to be, but very recently, so we've just turned into 2023. Very recently in the journal Cell, David Sinclair out of Harvard in his lab published on a mouse study. And I had read it a while ago because it was in preprint, but what they did was showed basically that aging happens in the epigenome. And so and specifically with sort of scrambles to DNA methylation. So patterns of methylation on our DNA change with aging. And in an animal model, they were able to create age, and then they were actually able to restore youth in this animal model by reordering DNA methylation. And so I think we might be touching closer on root cause. I really think so. And I'll say, when we look at epigenetics, when we look at DNA methylation in particular, as compared to telomere length, I still think, though, telomere length, it's not a bad biomarker to consider. If you really want a good snapshot of everything that may be associated with aging, but I think we're touching on some kind of extraordinary truth the more we get into epigenetics. It's really amazing. Can I say one other thing, and then I'll...
Yeah, go for it. Yeah, I think we're at the threshold. I mean, this is
So
it's an amazing science. Yeah.
So one of the things that Sinclair said in that paper is that there's a sort of a breakdown in epigenetic language that happens when we age. Like, it becomes scrambled, or aberrant is one of the terms that's used in the scientific literature, but it's becomes damaged, just from the wear and tear of our exposures. But you know what? There's another group of scientists, and I'm in this latter camp, where in fact there are very predictable changes that happen with aging. That's not quite this scramble. Yeah, if you're consuming glyphosate all day and you're being irradiated and you've got a burden of mercury, there's going to be some clear damage happening. But there's very predictable negative changes that happen when you walk the aging journey. And those changes increase inflammation. Those changes increase our risk for cancer profoundly. It's like all of the chronic diseases of aging are sort of built into the aging journey itself. And so I think that there's a programmed phenomena. I guess that's what I'm getting at. I think that there's some we're programmed to become more vulnerable to these diseases as we age. And I think that that's another massive promise. The fact that our diet and lifestyle intervention was able to kind of sweet talk it towards something younger. And of course, sky's the limit with the science here on sweet talking our epigenome. But I just think we're at a real threshold here in the longevity science.
Yeah, no, and I think we're going to be even more exacting as the years go on with the real supercomputers that we have that can crunch the data. The more and more we collect, the more and more we can sort of recognize patterns. I mean, this is what this is. When we look at the methylation and we look at the person, the individual, and what their regions look like and what diseases they do or don't have in their biological age versus chronological age, as we get all this data and really can mine it, I mean, we're going to come up with much more exacting science later on. But I think let's just backpedal a little bit to what you did in your study, which I think is phenomenal. In a 2-month period, 8 weeks, you were able to literally show that these individuals took 3 years off their biologic age. Oh my goodness. Hi, sweetie.
You've got home from school.
That's awesome.
Say a quick hi, and then I need to keep talking.
Say hi. Oh my gosh. Oh, I got 2 little girls. So how precious. Say hello. Hi, how are you? Aloha, we say in Hawaii. Hi.
You can say hi.
He's being shy. That's fine. That's
All right,
just fine. So I think it's phenomenal that not only you showed this reversal, if you will, or aging backwards, in the popular terminology, but that it happened so quickly. I mean, 8 weeks. Most studies are not of that short length, but tell us a little bit more about the study and the intervention, what you actually did and what was different maybe.
Yes.
Yeah, I just love to hear about the details a little
It's
bit
pretty,
more.
and if I had, because I was a clinician, or I am a clinician, I mean, I had to think about a realistic time frame. You know, as a doctor, 8 weeks is, you know, if you get people to really adhere strictly for 8 weeks, you're doing an amazing job. Now, if I had only consulted with scientists, they would say 6 months at a minimum, Kara, 6 months at a minimum. But you know, when you're working with real life human beings, right? How realistic is that to prescribe something fairly rigorous to, you know, if they haven't done something like that before. Anyway, it is. So we had to prescribe something that it's a multimodal intervention. It included an exercise prescription. We wanted people to engage in a twice daily meditation, and we wanted people to sleep enough. You know, we supported them with sleep hygiene tips and so forth. And then, of course, we had them adhere to our diet. And we gave 2 supplements. We gave a greens powder and a probiotic to them, pretty simple supplements. Each of the interventions was built around sweet talking DNA methylation. So there was evidence in the literature for every, like, brick by brick, how we built this, that it was favorable to DNA methylation. There was a huge lack of human data, however. So we were drawing on, you know, a knowledge of biochemistry, but like in vitro studies, so cell studies, and animal studies primarily. There's literature in exercise and actually meditation in humans. They've been looking at that for longer, but certainly, especially with regard to nutrition, you know, a lot of what we were doing was extrapolating from humans, or excuse me, from animals and cells. So the diet is, so let me say, as we age, we methylate less efficiently as we age, and DNA methylation is no exception. So we need to have a methylation rich diet. We need to have a diet that's packed with folate, that's got some B12 in it, has choline, has betaine, you know, has all of the accessory nutrients needed for optimal methylation. That is essential. I think one of the very cool aha moments for us was realizing that these polyphenols compounds, the colors in fruits and veg, are epinutrient regular. We call all of them epinutrients, but these guys are like, these seem to direct where those red lollipops go. We call them methylation adaptogens colloquially, but they're traffic directors for how methylation is happening on the genome. I really think. And so green tea, curcumin, luteolin, quercetin, what else? Sulforaphane, resveratrol, and on and on. I have 30 pages, a 30-page epinutrient appendix in my book. There are zillions of these beautiful compounds found in, you know, the foods that we're eating all of the time. I mean, even the pickiest eater is likely eating some epinutrients. But if we can pack every forkful with this epinutrient information, I think it's important and impressive and very possible. And you know, the outcome by building such an intentional intervention was that we really changed gene expression towards a more youthful pattern in our participants with this intervention.
Yeah, wow. The polyphenols are just incredibly amazing. And
Yes.
in the colorful vegetables and fruits, I mean, I just, one of my favorite things to share with people is that I always recommend an adding rather than subtracting approach. I mean, there's really only 3 things to subtract, right? It's just the highly processed crap, the highly processed sugars, the highly processed flours, the highly processed seed oils. I mean, you subtract those 3 things and you just add all of the rainbow. I mean, go to a farmer's market, any place tropical or any place that has giant farmers markets, you'll see so many things that the overwhelming majority of us sadly don't consume, yet we could be, right? I mean, there's thousands and thousands of edible plants out there that we never even touch in our lifetimes. And it's so sad. We could be dipping into these amazing phytonutrients that we're not using to our advantage. And so with your study group, how did you get them to do that? You did the greens powder and the probiotic, but was the nutritionist, dietitian that worked with them, were they making sure they eliminated processed foods, or like, what did that even look like? I'm just curious.
Yeah, really good question. And I want to come back to some other nutrients that are really important, like, you know, the animal products that we included in our study, and mushrooms, the incredible mushrooms. So we have, I've got a nutrition training program at my clinic. We've got some really white hot, brilliant nutritionists working with us. And, we were given an unrestricted grant. This was an expensive study. We hired Health Gut Research Institute at my alma mater out in Portland to run the study. And I was PI and Brian Bradley, the director at Health Gut, was my co-PI in it. We wanted healthy middle-aged men. So methylation, as I said earlier, gets abnormal as we age. And so I wanted to look right in sort of the heart of when that starts to change. So our population was between the ages of 50 and 72, right when methylation changes. But we wanted them to be healthy. We didn't want to be studying a disease process and changing a disease process. We wanted to look at, as I said earlier, the negative changes that happen in the aging journey, even to healthy individuals. So it took us a while to fully recruit. We actually had to have a rolling recruitment to, be able to get enough folks just willing to adhere to a pretty involved protocol. And yes, they had to be willing to follow the diet. So, that if they were chosen to be in the study group, they had to agree to be able to adhere to that. Our nutrition team met with them at least weekly and more if they required it for the first month. And then as needed after that. I think without exception, the study participants wanted to continue with the nutrition team because it was so helpful. They had to follow, I like to say this is sort of funny, because it was a research study, everything had to be approved through our institutional review board. And
Sure.
so the nutritionists didn't get to coach in the way that we do in our practices all the time, kind of love on them and motivate them. They had to read these very sterile questions in a list. Do you have questions? Are you sleeping enough? Did you get your liver? But even with that kind of sterile contact, our participants, the adherence numbers were very, very high. I hope to actually publish on that, because I know that nutrition interventions are notoriously difficult, but we had really good adherence. And I'm certain it had to do with two things. One was that the nutrition touch points were essential. And the other thing is that they understood what they were doing. They knew this was a first of a kind study, and they knew that we were looking at gene expression, and it had never been done before. And I think that they felt some sort of motivation just from that.
Yeah, no, that I think that part is so critical. And in the studies, like you mentioned appropriately, that have been done with nutritional research, I'm kind of embarrassed at many of them because, most of them, we call them studies, but it's a freaking survey. It's not really a study. It's observational data. You can't draw conclusions from it. There's so much.
And sometimes it's a year. Let's do a dietary recall over a year.
I could barely remember what I ate yesterday. I mean, I'm supposed to remember what I ate for a whole calendar year. And
it's so kind of insane.
Yeah, what you did was really cutting edge as far as, you're very structured. You had at least a weekly meeting with the dietitian nutritionist in the beginning, and then as much as they needed. And I mean, so important because, like you said, your adherence was really, really good. And two things I wanted to comment. One, that you started with a quote unquote healthy, group, which I think that you saw, amazing results for that 3 years, right? Of getting younger, if you will, biologically. But if you started maybe with a sicker cohort, maybe you could have even made a grander, bigger, difference, maybe 5 years, who knows? But I think it's kind of cool. How did you do that? Did you just basically exclude anybody that had any diagnosed medical condition, or what did that look like?
Yeah, that's a really good question. So yes, in the research setting, the definition of health is the absence of disease, which is, which is kind of lame. It would be nice for us to look at, well, actually we are now. I'll talk about that in a second. Yeah. So they couldn't be on, most medications. We just excluded certain diagnoses, et cetera. Yeah. We wanted to limit that. They actually had to wash out of supplements. We only allowed them to continue their vitamin D had that been prescribed. So yeah, they were basically healthy guys, or basically with an absence of disease. We just submitted for publication, and it should be up on a preprint server pretty soon, a case series. So just 6 individuals who've done the program since our first study came out. And these were biologically younger at baseline, and women. Actually, our first study is men, so this next publication is in women, and they were biologically younger at baseline. That wasn't the case with our men in our first study, but it's interesting to see that, I think with the exception of one who was she wasn't older than her chronological age. Her bio age matched her chrono age. Everybody was, fairly significantly younger at start, and they got younger still. It's pretty cool.
Yeah, no, that's amazing. And I think I'm sure you got some criticism on that. I perfectly understand it, why just include the dudes in the first go round, because that age group you mentioned, obviously the women are going to be either premenopausal, perimenopausal, postmenopausal, and hormonal influence is definitely going to play into that. And it would just be too challenging to tease all that out at the first, run through, if you will. So I can totally appreciate that. I'm not going to be critical at all. I get it. But I can see how others might on the first go round. But I think it sounds like, this will be the first of many groups that you'll be studying over the, next decade, I'm sure. But I just found that the data that you had, even in that short time in supposedly, healthy people, those that didn't have diagnosed conditions, is phenomenal, because I really feel like the strength and the magnitude could be even greater if you started with somebody that maybe, had some conditions, whether it be diabetes, hypertension, all the stuff that you and I see every single day that are so dang common, probably have more room to improve in that respect,
The literature certainly suggests that, like, a type 2 diabetic is, it's been reported they're anywhere from 6 to 9 years older. And I'm sure they're, I'm sure we could see them older, or even older than that, depending on where they are on that diabetic journey. Yeah, no doubt about it. So if we were to look at individuals with certain disease processes, yes, I would anticipate the potential for even greater reversal. I debate with my friend Lucia Aronica, she's a scientist, and she teaches at Stanford, and she thinks that it might take longer, but she's not a clinician. So you and I know, seeing patients, that you can, if somebody who's committed in 8 weeks, I mean, you can work some pretty serious miracles. So as a PhD, she debates, and I actually included a quote on our little debate in the book, saying that she thinks it might take longer, but we could see blood sugar, insulin drop like a stone if somebody really hangs in there. I mean, you can transform in 8 weeks. So I think we could potentially see it.
Yeah, no, I mean, I've literally seen type 2 diabetics in that same 8-week period no longer be type 2 diabetics, because they've changed their diet, they've changed their movement patterns, they've changed their, timing of their foods, whether it be a version of intermittent fasting. I think you use like a overnight fast, like a 12-hour circadian fast in the group, which is something I universally really urge people to do, because I feel like it's so easy. Like most of us hopefully are trying to get 8 hours of sleep. You tag 2 hours on either end of that. Like, that's not that hard. And yet we see good, results just with that minimal amount. It's not a challenge for most people. So I appreciate that you included that. I think that's amazing. One thing I wanted to ask about the exercise kind of protocol, if you will. I know you had to have some kind of movement, but what did that look like in most of the group? Was walking perfectly adequate to accomplish the exercise movement goal? Tell us a little bit more about exercise and what your thoughts are on what are the best exercises and what kind of combinations and things like that for anti-aging, if you will.
Well, for this intervention, I want it to be broadly adoptable. I want everybody to be able, this particular design is not for the avid biohacker who's on one meal a day and, doing HIIT and like whatever on rapamycin, whatever. It's not, this is to be broadly adoptable. And when you look at the economics of even a very limited bioage slowdown, it's staggering. Like we really need to be adopting some of these principles. So exercise fit into that. What I want people to just be doing it, just get into the game. So our prescription was very simple. It's a minimum of 30 minutes, 5 days a week with a perceived exertion. So you decide yourself that that you're at about 60 to 80% of your max. So do whatever you want, at least a half an hour. So yeah, of course it can be walking, it can be cycling, it can be jogging, it can be, doing some resistance training if you want. It could be cleaning your house, it could be gardening, just whatever gets you moving, gets you sweating a little bit. You should be able to still carry on a conversation 60 to 80%, but when you're up at 80%, it might be a little bit higher. But you're consistently doing that 5 days a week. Now, when we look in the literature, and I move to the next generation intervention, we'll study, a more refined exercise prescription where cardio is involved, resistance training really needs to be involved, high intensity should be involved, where we touch up at our max, a few times, maybe once or twice a week. I think a exercise package like that is optimal. But optimal is enemy of the just do it for those of us who struggle with exercise. So
yeah, the optimal and the complexity, right? We always say is the enemy of execution. And I really believe that it has to just be something that's doable on the daily. I mean, just move your body in a way that you can do. People always ask me, what's the best exercise? What's the best? I said, well, what will you do every single day? For you, that's the best exercise right now, today, is that totally. Whatever that is, whether it's a walk, whether it's cycling like you love to do, whether it's surfing like I love to do, or hiking, climbing, whatever that is, like just do something every day. And you even gave them 2 days off, right? 30 minutes, 5 days a week. That's kind of the standard 150 minutes. The standard recommendation. You met that, the 150 minutes, but you can do more. You can do, you can vary it. I'm sure they could do like 10 minutes after, like what I tell people is 10 minutes after every meal, you've hit 30 minutes right there. And you didn't have to block out a 30-minute chunk. And we know that metabolically speaking, this is better for your blood sugar balance, for decreasing that glucose and corresponding insulin spike, and all the risk factors for type 2 diabetes, insulin, resistance, all of that can go down dramatically with just a little bit of movement after a meal. My favorite at home right now is we turn on some music and we do a dance party because it's freaking cold outside. It's like 5 degrees outside. I don't want to go for a walk.
Right.
So we'll play a couple songs. The kids bounce around. We just
awesome.
Kind of have fun with it. And that's kind of our after meal movement. We'd have a little Hemingway dance party. So
that's fun. That's cool. Yeah.
I'm sure you got a lot of those that'll be happening real soon if they're not already.
For sure. Exercise is extraordinary for a handful of reasons. I want to say that it is really an anti-aging elixir. It's like it's if we could bottle it, if we could encapsulate it, it would be the most potent drug out there. It is able to reverse bioage in and of itself. And there was a cool study by Mayo Clinic a handful of years back that actually found greater benefit in community exercise. So your dance party, doing your movement with others. I mean, exercise, no matter what you're doing, is beneficial. But there's if you're open to doing it with community, you might get a little bit more bang for your buck. That's what they argued. I'm a cyclist though, which tends to I'm a little more solo about it, but that's okay.
Yeah, that's a little harder. Yeah, you got a big group of cyclists together, and I don't know, it may be better. I used to bike a lot, and now I'm kind of scared of it because a lot of places they don't really look and watch for you, and I feel like I'm a target. And so I only like to bike on a trail that doesn't allow vehicles because I worry more about them than I worry about me injuring myself on my own. But I think you're right awesome with the company. Do it with company, and that obviously I think does a couple of things. One, the enjoyment, the camaraderie that occurs, the oxytocin that gets released when you're in community, which is like the antithesis
That's a longevity
of our classic stress hormones that get amped up in other conditions. Maybe speak to that part. I feel like I've heard you speak about stress before and how that's maybe fuel for the fire of inflammation and aging itself. And so the best anti-stress techniques, we've just spoken about one of my favorites, which is exercise. I love that for an anti-stress, but talk a little bit about the meditation you prescribed in your protocol, and then the other techniques that you'd recommend as far as tackling that, I think, really big risk factor to aging, which is stress. Maybe just speak to that a little bit.
Yeah, I would say that I was having this conversation with someone else recently about what's the heavier lifter in our intervention? Was it our meditation prescription, or was it diet? And I think the jury is really out. I mean, excessive stress is toxic to our bodies. Excessive stress is absolutely toxic to us. And for me, it was hit home when I read the paper by Zanis et al. that looks at the Horvath clock that we used and demonstrated that a full 25% of it is regulated by cortisol, by glucocorticoid response elements. So those particular methylation, the genes that those methylation groups are on, the region is regulated by cortisol. So stress turns these on and promotes the aging journey, the stress response. 25%. There's no other variable that has such a direct effect on aging as stress, as and I think for me that really made me it may be, we could probably handle our McDonald's if we simply, I'm not saying that. It wasn't my out loud voice.
Don't go out and get McDonald's. Come on, we know better.
But stress is a massive, massive driver of the aging journey. Toxic stress is a massive driver. And we talk a lot about it. We pay a lot of lip service to it. But are we really sinking in to remedying it? And so in our study, we prescribed a very simple relaxation response created by the late, great Herbert Benson out of Harvard, who studied meditation. He called it the relaxation response because back when he was studying in the 70s, he didn't want it to sound too woo-woo, and so he just labeled it quite simply relaxation response. And it's an easy breathing exercise. We wanted our participants to do it 2 days a week, 2 times per day. The literature on practicing meditation, on yoga, Tai Chi, etc., all of these balancing interventions, actually exercise as well, is that those who are practiced at doing it are biologically younger. There is clear benefit. And the practice, actually engaging in good habits over time, allows lasting changes to sort of generations of cells in our body. So the genetic changes, the gene expression changes that we're able to make with beginning our practices will transform us more and more with the extension, with the longevity and the commitment to our practices. However, one practice, like one meditation practice, one yoga practice, even a single exercise event can show favorable changes to gene expression. So just getting in the party, just starting the party itself will yield favorable benefits. But that lasting habit, the benefits spread like wildfire and influence us, deeper and more profoundly towards a more youthful pattern of gene expression.
Yeah, no.
And actually, let me throw out one other point too around exercise, because I just think it's really cool. There's a group of researchers who are arguing that the way that exercise works its benefit is through changing gene expression, and particularly they were talking about DNA methylation. And the older we get, the more impactful exercise is on DNA methylation, and in particular, protecting us from cancer. It helps turn genes on that protect us from cancer, a whole group of genes, a massive group of genes called tumor suppressor genes. We inhibit these as we age, but exercise and our other good lifestyle habits can, turn them back on.
I love that. It's not too late. It's never too late. And the effect you just shared as you age is even more profound. So
isn't that amazing?
You even get more bang for your buck.
Exactly.
So if you're turning 50 like me next year and you've never exercised a day in your life, it's okay. Start today. Today's a new day, right? The first day of the rest of your life. That's so amazing. I love that.
It's really cool.
In the meditation practice that you were doing in your study, the twice a day, was that just a couple of minutes? What did that look like? I'm just curious.
It was 10 minutes twice a day.
Okay.
It was 10 minutes.
That's pretty manageable. Yeah, no, I like that. I think when I speak to that and share that with people, they always have this in their mind that it's got to be like an hour or minimum 30 minutes. And I just don't have time for that. I got, kids and work and all these athletic things I got to do in the afternoon with my teenage kids or whatever the excuse is, they don't have the time. And so 10 minutes, I think, is pretty doable. And what I like to do, and maybe this is cheating, I don't know if this works in your protocol, but I like to kind of kill, two birds with one stone, so to speak. And I go out for a walk in nature and I don't bring my phone. I don't have anything that distracts me. I practice. I have a couple different breathing techniques that I do while I'm walking and I'm in nature, getting my sunlight, the vitamin D, getting that sort of vitamin N, I like to call it, for nature, just that fresh air. And I'm breathing and I'm not doing hard, this doesn't count for my sort of resistance training or aerobics, but I feel like the movement is good too. So I try to tell people, if you can, combine those into one little walking event in the morning and the evening, that's a great place to start. Just don't bring your phone. Like, don't be distracted. Just be in the moment, really appreciating your breath and your existence and all those things. And I feel like it can kind of have both of those effects. Do you feel similarly?
Yeah. Or? Oh, absolutely. So we studied, we had to have a study design for our trial. And so we used Herbert Benson's relaxation response twice a day. But 100%, if you look in the literature, all of these things are beneficial. And the combination of the movement in nature with sun, intentional breathing, absolutely. And I don't think that people need to do a full 10 minutes. That can be overwhelming for the uninitiated. There's an app out of University of Wisconsin called Healthy Minds that I like a lot. It's totally free. These guys study the benefits of meditation, and you can download this app. I use it routinely, and it's got 1-minute meditations, and I've used it. Like, you could just slap that baby on and just have this nice calming voice, talk you down and just focus on breathing. And I love it. And it's got meditations for exercise. So if you're out there on your bike and you actually want to listen to a meditation, which will still keep you focused, or walking or whatever, you could do that. Sleep meditations, etc. So all sorts of really easy tools for any length of time. We just need to get started and enter into it, in whatever way works for us.
Yes, I love it. The 1-minute meditation. Start there. I think we can all do that. That's like 5 or 6 breaths. Come on.
Yeah, that's exactly right. There's no excuse for not doing that. Yeah.
We can start today with a win, with the 1-minute meditation.
1-minute meditation. You can do that. Yeah.
Anybody can do that. I'm with you. You got to start. Yeah. And I think what happens. Free. Yeah, it's free. And when you do it, you're like, gosh, this was amazing. How about like 2 minutes tomorrow? And then maybe it's 5 or 10. And then you're like addicted. Yeah. You're like, why would I ever want to stop? I feel so good. That's how I feel about exercise. I do something every day, 7 days a week. I do something. I don't do hard things on a couple of the days, but I do something every day because I just feel good. Why wouldn't I?
I know.
I want to feel good. And I think meditation is similar to that you just, it's tangible. It's noticeable, even in the short 1 or 2 minute meditations. What a beautiful place to start. I love that. I'm going to drop that in there. University of Wisconsin, Healthy Minds. I wrote it down while we were talking, because I could use one of those 1-minute meditations sometimes, because, when your kids get you riled up, sometimes you need a, mommy or daddy timeout.
Just take your 1 minute. 100%. When I was doing, when I was promoting the book heavily, and I was like, my whole schedule was just this intense journey of interviews, and it was unlike anything I'd ever experienced in my life. And my life's pretty busy. I would take those minutes and I would just disappear in the bathroom or in my car before I went into my office. And I used them all the time.
Awesome. Well, let's just speak to that. We haven't specifically mentioned your amazing book, Younger You, a scientifically proven program for lowering biological age and living longer, better. Maybe just speak to that for a moment. And then any last sort of parting thoughts you wanted to share. I want to be respectful of your time.
Thanks. Yeah. So Younger You is the how-to of what we did in our research study, but it's a lot more. I mean, it has a ton of recipes that are beautiful and delicious from our fabulous nutrition team. We've got the Everyday Younger You, which is an easier version, or if you're intimidated about following plans, just jump into the nutrition appendix, which is probably my favorite part of the book, and look at all you're doing right already if you need a little validation, and then stuff you can just add in, like in using your method. In the book, I talk about, epigenetics through the lifespan. So there's a pregnancy. I created because epigenetics, DNA methylation, is such a massive part of pregnancy and pre-pregnancy. I created a Younger You hybrid. I felt remiss if I didn't. So you can use this for the nutritionally demanding time of pregnancy or pre-pregnancy planning, so that you're just nourishing your baby in all of the important nutrients and handing down that beautiful information. So the book is a lot more than just bioage reversal in a middle-aged population. There's something in it for everybody. And it's exciting to me. I think being able to see gene expression and being able to kind of be in the driver's seat of optimizing ours is really cool. The one other thing I'll add to is that we have a cookbook out now called Better Broths and Healing Tonics. And it's a companion cookbook to Younger You. So anybody interested in drilling down into our recipes and just kind of expanding on it, look at Better Broths and Healing Tonics. It's a really cool book also.
Awesome. Awesome. And I'll make the plug that, you mentioned specifically, the importance of, being healthy when you're planning, to be pregnant. I would say that, the obvious thing is we're thinking about women, but dudes need to have this
Yes,
help too,
100%.
because the fertility rates in dudes has been declining rapidly in the last 50
Yes.
years, as women too. And we both need
Yes.
this help. So it's not just for women.
Yes.
This is for dudes as well. We can all benefit from optimizing all of this.
Men send their epigenetic information, and their sperm is absolutely sent on to their kids. Absolutely. Men are absolutely 100% in the world of epigenetics of gene expression. That information you're handing out to your kiddo is will, without question, make a difference in your offspring, and actually generations past that to come. So yeah, dudes are right in the mix.
Absolutely. So you don't get a get out of jail free card, guys. You gotta be doing it with your significant other. This is important.
Yeah.
We can all benefit. That's just great stuff, man. Thank you so much, Kara. It's been
100%.
amazing.
Yeah.
Really appreciate you taking this time, and tell us how people can reach out to you. Where can they find you, follow you,
Yep.
grab the book, all that good stuff.
Yeah. So there's a few things that you can do if you want. You can, first of all, get your bioage through our clinic, and in fact have a consultation with one of our amazing nutritionists who have this stuff in their epigenome, and that is really affordable. It's $299 to do the whole thing. By the way, when we were running our study, one test was $1,200. So it's come down in cost tremendously.
Yay.
So we have access on that at our clinic, and you can access our clinic at just Dr. Kara, Fitzgerald.com. You can find Younger You and all things related to the book at youngeryouprogram.com. So yeah, we have newsletters. I'm on social media at Instagram and all that good stuff as well.
Awesome. And Dr. Kara does amazing Instagram lives. They just pop up in my feed from time to time. I like to send in some love on the chat, and she's doing great things in the world. And I'm just so grateful that you took this time to share with our audience. So really appreciate you.
My pleasure.
Thanks again for coming on.
I hope you enjoyed this episode of the podcast. Please make sure you hit the subscribe button and the notification bell so you never miss out on any future episode. And I'd love to hear your comments and feedback. If there's any topic you'd love to hear about, you're dying to know, burning questions, please comment below and let me know what future topics are of interest to you.